welcome back. Today we're going to talk about definitions, and this is going to be nice and short because definitions are the basis of what we do. When we talk about definitions, we're talking about what makes something what it is. And so we have to be very explicit but very inclusive. And so definitions are going to be under the classification of biconditional statements. But the if and only if part of a biconditional is going to be implied. Remember those two conditions, the converse and the conditional? Well, that's going to be part of all this, and it's going to have to work both ways. It's going to have to be true to be a definition. Here's an example. A triangle is a three-sided polygon. If we write this as a biconditional, we could say a figure is a triangle if and only if it has three sides. Because if I read it one way, if a figure is a triangle, then it has three sides. That is true. If I read it the other way, if it has three sides, then it is a triangle. It's also true. So it has to be a true biconditional statement. So what we're going to do in example 4 is we're going to take a couple of definitions that don't have the if and only if, and we're going to rewrite them with the if and only if completed. A segment bisector, this shouldn't be segments, it's not possessive. A segment bisector is a ray, segment, or line that divides a segment into two congruent segments. If I want to draw this out, this is what it looks like. If I have a segment here, and I'm going to call this the bisector, which means that these two sides here are going to be congruent, so I'll mark them as such. Then that means that whatever this is here, this could be a point, ray, segment, or line, and it's going to divide it exactly in half. Well, when I write this as a biconditional, it has to be inclusive. It has to include the fact that a bisector is something that cuts it into congruent segments, and if it cuts it into congruent segments, then it is a bisector. So let's see. We could write it like this. A ray segment, or line is a segment bisector that's the first part. And then comes the if and only if, and I'm going to write it with its abbreviation, if and only if it cuts the segment into two congruent segments. And I will abbreviate segments as segs. So that's how you do that. You have to include both pieces, both conditions, meaning the first part, and the second part, which divides it. Okay? Down here, I've made a bit of a mistake. I've given you the same one. And so I'm going to cross this out. And I'm going to give you one to do. And it's going to look something like this. This is going to be the definition. A quadrilateral is a four-sided polygon. Okay? So in general, there's two pieces, four-sided polygon and quadrilateral. You can look back to these last two examples and see how to do that, but go ahead and write a biconditional using if and only if. Thanks for watching, guys. That's the basics on definitions. We'll see you next time.